Okay, this is a private course. This is all wireless networks or public-private networks. The scenario is kind of to take a private-public network and kind of put it together. So what we want to do is we want to break this problem down into nice, logical, easy-to-achieve steps. Part of really good network engineering is being able to break down the problem into its component steps so you know what you're going to do. So we want to know what each of the components in the system design are going to be proposed. So we know we want to build a wireless network, and we know that we want to build a wireless network for guests or public access, and we want to build one for internal. We're going to want to make sure that when we finish this project out that we have a really good wiring diagram on how we're going to connect each of these components up. Even though you've got people that are using wireless devices, whether it's their laptop or their iPhone or their Android device or anything else, we want to know how the major components from not just the phone or anything else, but we want to know from the wireless access point all the way back through the building wiring to the wiring closet to where all the routers and switches are, so we can kind of put all this together. And then we want to make sure that we're matching all the things that we need for our security, our configuration policies, and then any other policy alignment that we need to do. So for a guest network, we may have a terms of service that we need them to agree to, and then we'll record their IP address and their MAC address, and we consider that good. For an internal network, we want to make sure that the terms of service, and then there's a place to put in a username and a password. So by following each of these steps and breaking it down into components that are easily managed, it will help you visualize what you're trying to do and make sure that you don't miss anything, because that's one of the easiest things to do when it goes into networking, is missing something. So essentially what we're going to do is we're going to build two networks. We're going to build an internal one for all of our employees, and then we're going to build an external one for all of our guests, or for this case it's a college. So we're going to build one for all of our instructors and administrators, and then we're going to build a different one for our external. So each one has a different security management policy and configuration process, but we want to make it really easy to manage. So we want to make sure that everything can be centrally managed. The internal network is going to require access to all the internal assets, such as student records, internal websites where we're collaborating and sharing documents like SharePoint. It's going to have our authentication server, anything that's policy-driven, that's design-driven, URL filters, protocol blocking, anything that we need for the internal network to make sure that the company can still do business. And then we want to be able to put all of our students and external users. So it's going to require some form of authentication. Right? If it's students and they actually need to authenticate against the actual network, probably, maybe. We don't know the answer yet. But what we do want to do is make sure that they can at least go back through to the main campus site and authenticate and get to their student records and their financial aid and all the other things that they want. We may have to do some bandwidth shaping because people will like to download big, huge attachments. You have students, when they're designing their final projects, always have huge 25 megabit attachments to email. It's interesting. And then any kind of URL filtering, we may not want them going off to the Pirate Bay or BitTorrent, or we may not want them going to porn sites or anything else. And then we may want to do some protocol blocking because we may not want them to go out and on the student network use streaming video, do iTunes Radio or Pandora Radio. We may want to push them off onto something else for that because it's basically their way of doing things. Now we have to make some assumptions. All network designs start off with assumptions. So for a hardware type, we're basically going to use Cisco network devices. I'm not going to focus on F5 or Aruba or anything else that's basically enterprise-ready devices. We have an audience. We have two distinct users, internal and external. We've kind of identified those. One is students, one is internal staff. We know that people are going to be on mobile devices. We know that they're going to have tablets, smartphones, and other types of mobile devices. Both the internal and external clients will have any device that you can imagine. And that we're basically going to be building two configurations, but they're going to need to be managed appropriately and semi-separately, right? So that we can make sure that if we push a change off to the wireless routers on the student network, that change isn't pushed off to the instructor network. And then budget. There's always money going to be involved. So in this case, we're going to assume that there are no budget configurations. And we have the budget to accomplish our task, and that we can use basically a best case. And we don't necessarily want or need to buy the most expensive equipment on the planet, but we should be reasonable and explain why these particular devices are the best ones that we can afford to get. So the external network, what we want to do is we want to start figuring out our bandwidth, because our bandwidth is going to tell us everything that we need to know about it and what kind of access points and components that we're going to need. So we're going to take a look at two protocols, 802.11n, which is the newest one and the fastest one at 150 megabits per second, and then 802.11g, which is 54. G is less expensive. G has less bandwidth, but depending on what we need for our external network, we may know what we need to do. We know that we want to offer web-based email, HTTP, HTTPS. We'll have to do DNS, and we don't want access to internal servers like payroll or other stuff, because student with a payroll access would be bad. We want to limit the amount of bandwidth available to the network users. So we have to figure out how many users we're going to have. So we're going to make an assumption of about 1,000 users at any given time, right? We know that if we have a student body of X amount, that not everyone's going to be on it all the time. Classes are usually run from early in the morning till late in the evening, late at night. So we're going to have people in and out of the building, but we're not going to have anybody there for that entire amount of time consuming bandwidth all the time. And we're going to assume that it's all light. It's email and HTTPS traffic only. Right? We're not going to offer voice over IP, no stream music, no video, or anything else like that. We want to make sure that we limit that so that we can get as much stuff reserved for the internal users as possible. So when we're calculating the bandwidth, we ask ourselves what services, and we've answered those services: HTTPS, DNS, email, no VoIP. Well, using a bandwidth calculator will help you estimate your needs, and it's so much easier than trying to do the mathematics by octets or mathematics by megabits and kilobits. There's a lot of math that can go around. So if we have 1,000 users and we used a Cisco bandwidth calculator, we basically come up with 220 megabits per second, or basically not even two. We'll probably need a second one of the wireless G access points just for the external users. And then that also gives us a little bit of room to grow. 220, 300 megabits if we buy two of them. We can pretty much do okay, but if we assume that not all users are on at the same time, we can probably get away with one wireless G and not sweat it too badly. So it depends. Do we want to plan for growth? Do we want to plan for anything that we didn't calculate right with a bandwidth calculator? You know, technically, because of the assumption that we have the money to do this, that we're going to want to have two wireless G routers. And there's some additional resources that are going to help you understand bandwidth calculations so much easier. The bandwidth calculator, bandwidth pool, is actually based on the Cisco device. The Cisco Wireless Design Guide is going to totally help you figure out how to do all this stuff. And then forecasting availability is another really good one, especially on high-density Wi-Fi design, especially on a campus network or a large corporation network. So if you're at Microsoft or Amazon, you really want to be able to forecast how the availability of all those access points are going to work for you. And you tie that in with the wireless design guide and the bandwidth calculator, and you're going to do really, really well. Now, on the internal users, we'll always have more customers than we have staff. So we're going to make an assumption that we have 10% of the internal users that we have for external users, so that's going to give me about 100 users, right? And they're going to have a lot of internet-dependent services. So we're going to have human resources and benefits and maybe some cloud-based services, voice over IP. We're going to be doing video like we're doing now. You know, other streaming services, maybe the instructor wants to listen to a little bit of music, kind of set the mood for teaching. It just all depends. So we're going to assume that our internal users are all going to be heavy bandwidth users. So for those 100 users, we're going to come out to 170 megabits per second as high. So its own wireless G network, and you know that some people are home all day, some people are in the office, only occasionally we all go to lunch, and you can actually watch bandwidth spike in the morning when everybody logs in, then it kind of tapers off and it goes to lunch, and it kind of flatlines and it spikes when everybody comes back in from lunch and kind of tapers off to the end of the day. So we've got two big spikes, and we want to make sure that our network is set for those two big spikes, that log in, log off, and first initial email of the morning, right? But again, we're going to make the assumption that not everyone's going to be on at the same time or using all those heavy services at the same time. So if we have 220 megabits, then we can plan for optimal capacity if we purchase one wireless G router underneath the assumption, or we can purchase two. That will allow us some room for growth, right? We need to space these wireless routers every 300 to 350 feet. So if we have a building that's 2,000 feet long, 1,000 feet wide, and we put 14 wireless access points on each floor, and that should give us the right amount of coverage for that floor and give everybody a nice solid signal as they move their laptop or their phone or whatever across the building when they're walking up and down the hallway. So some wireless nodes will overlap, so you're going to want to make sure that there's an authentication token dropped on when someone logs in. There's a cookie, and that this authentication token is only good for X amount of time, so they have to keep on redoing it every day, right? So some providers will try to do security by keeping the wireless signal to the minimum outside the building. You can either coat the inside of the building wall with Wi-Fi reflective paint, or you can just let the nodes overlap just a little bit. It's not going to hurt anything. You just don't want that node reaching all the way out in the parking lot. So I can be sitting in my car and going ahead and latching onto your Wi-Fi network, and that's how some people were able to break into Lowe's. They actually were able to tap into the internal employee network at Lowe's from the parking lot, and were intercepting credit card data because the nodes were shaped wrong. So the Wi-Fi signal reached all the way out in the parking lot. And who's going to pay attention to a couple guys sitting in a parking lot, right? So for the internal guys, we have a lower number of internal users, but we still need that bandwidth, right? So I would like to, personally, I'm a big fan of spare capacity. And so as we wire the internal network the same way as the external network, but let's just go ahead and doing the 14 WAPs for the internal network as well. Right? It allows for growth, then there's some redundancy and failover, and then allows for any kind of mobile systems overhead that may actually end up happening if people are on their 3G or on their 4G phones or on their LTE phones. So we kind of want to make sure that we have some redundancy and some failover, and that's why if we have all those extra wireless access points in this huge 2,000 by 1,000 foot building, we can pretty much so cover the entire floor then with using 28 802.11g wireless access points. So we'll need to place them again about 350 feet from the external walls. So we kind of not going to push them down the middle of the building. We're going to kind of push them at the 1/3 point, 1/3 from the right wall and 1/3 from the left wall, right? And then we're going to want some range extender antennas to give us the extra range that we need. So you can actually buy range extender antennas. There's basically extra large antennas that will work with these things. So we're going to be offering 300 megabits of bandwidth per second to both our internal and external customers. And our wired network is the standard 1 gig, which is pretty much so what you're going to see for every wired network, leaving about 420 megabytes per second for our wired users. So if you bring in your laptop and you jack it into the wall, there's still some space for you on that network. So we can pretty much so not worry about the rest of the internal network. We just need to make sure that everything's wired correctly when we get down into the routing closet, and that we have all the other stuff. Money is always going to come up. So what I did is I found some wireless G access points from Cisco, AK940s. Basically, you can buy them in 10 packs. And they're about 600 a piece, so if we spend $14,400 per floor, that's actually really not that bad, right? But one thing to remember, we have to do this per floor. Concrete and rebar, so concrete and steel, will deflect wireless signals between the floors. So it's really hard to punch through with a 2.4 gigahertz or a 5 gigahertz channel through concrete and rebar. But most of the internal construction, if it's not wood, is going to be drywall and aluminum spars. And aluminum will actually reflect those signals all over the place. So they're really, once they're fixed, you're going to get a constant reflection point, which is why you kind of get those dead zones in buildings, or you kind of have a hard time working the thing through the process of getting a signal. You watch your signal fade, you watch those bars go up, and you watch those bars go down. It's because of the drywall and the aluminum spars that are on the inside of the walls. So it kind of reflects what's going on with the signal strength inside those wireless routers, and this is really kind of a cool thing. But if you can buy it for $600 each, I'm sure you could probably get a deal with Cisco if you're going to buy 28 of them, or more if you wanted to cover an entire building or an entire campus. This is just the generic price that I was able to find online. All right. So, other equipment. For external users, we're going to provide what's called a guest access. We can use, there's a redirect feature in Cisco wireless access points that basically you can redirect any HTTP or HTTPS off to a sign-in page where they have to agree to the terms of service. That terms of service that person agrees to is going to be policy-driven. So your information security department, your legal department, and your human resources department are going to have what's called an acceptable use policy for your network, right? So once someone reads that whole terms of service, which odds are highly likely they won't, but it's there to cover the company or the schools against legal liability for whatever someone may do on the network, that alleviates the need for just having a read-only radio server on the external network. There's ways now you can tie everything together beautifully. We're going to want to do a subnet for external networks, so it's IP differently So it's going to be obvious. So if your external network is 192.168 private reserved space, and then your internal network is 172 or 1010, then you know that what's going on in 192 is only for your external clients, where you know what's going on in 172 is only for your internal. So you're basically wiring up two different networks. And what that's going to be is, in the language of Cisco routing, is basically what you're going to do is you're going to end up creating a fabric. Right? You're going to hear people talk about fabrics a lot. So when we do that subnet, we're actually creating a fabric called 192.168. And on that fabric, there's going to be authentication and DNS and ways for people to get to their school email and all the other things that they need to be able to do. So we're basically creating a Class B subnet because we have 1,000 people. And we want to make sure that we can do what we need to do, or you could actually break that subnet up into actual buildings, right? So if one building is 192.168.10, another building is 192.168.20, so 10 all belongs to administration building, 20 all belongs to the library, 30 all belongs to IT services. There's ways of narrowing down by subnet how and where those IP addresses belong, so you know if someone's doing something horrible, that you can actually pin them down to a building just by the IP address. So we were going to want a different or separate DNS system, but the good part is that our ISP provides a very robust DNS server. So we don't really have to build one for ourselves, because all of our external clients are going to be going off our network out to that DNS and then either back to the school or off to Google or Yahoo or Bing or wherever it is that they're traveling to. Right? We will want what's called a caching web proxy. Squid is an awesome caching web proxy, and what that will do is it will make the network look faster. So if someone's constantly going to CNN, if CNN is a very popular site at the school, Squid will actually cache all that and then only look for changes. So, a lot of content on the web is fairly static. So as Squid caches all this stuff, we can actually then turn around and use that data to figure out where the most popular sites are. Squid will automatically cache all those for us. Then we can also find out if people are doing horrible things. So if we all of a sudden have a porn site become the most popular place, then we can basically pin down and maybe block that by using a URL blocking program. Right? We'll want to filter out all the ports, so we're basically going to want to deny all, right, and our configuration for our firewall, deny all but HTTP, HTTPS, SMTP, POP3, secure SMTP, POP3. We may want to open up a little bit of Outlook. We may want to offer other services other than port 80 and port 25, 963. We may need to offer some authentication services. There's other things that we may want to do. But in general, because we want to limit what our external people do, we want to make sure that we're focusing just on the services that they want. And then what we will also want is what's called an intrusion prevention system, because we kind of want to make sure that if something quirky is happening on the network, someone's doing something, a little hacking, right? We want to find out, but we want the network to be able to self-heal. So an IPS, an intrusion prevention system, is a rule-based system that will essentially then look for a signature of a hacking attack and then drop that connection the minute it sees it. So it's a little bit more proactive in terms of how it does. An intrusion detection system, which is an earlier technology, will just detect it but won't do anything. And IPS will actually try to kill that connection. And then for our internal users, we need to authenticate them. So we want to make sure that they connect back to a Radius server that then ties back to Active Directory, or if we're on a Unix system that we're using LDAP, Lightweight Access Directory Protocol. Right? So we want to make sure there's some way to authenticate someone by a username and password. So we'll put our users on a separate subnet. I'm going to choose 172.11 for this so that we have a much bigger network so we can accommodate mobile devices and other things that people will bring along. We'll want our own DNS for our internal systems, so we can type in HR and end up at HR, or we can type in SharePoint and end up at our SharePoint collaboration server, right? But for anything external, we want to use our ISP's DNS because their system is big and beefy enough to manage all that for us. We don't want to filter any protocols. We want to allow everything because our internal staff are going to be going out to YouTube, surfing videos, or they're going to be building and creating videos like this and uploading them and downloading them. We'll want the same type of intrusion prevention system to ensure that hacking activity is caught. The good part is that some firewalls will do this automatically. It just all depends on what we want to buy. We will want some kind of load balancer. If we have that many people, 1,100 people or more doing this, we want to make sure that we balance the loads for the outbound traffic. So when we get to that point where we're pushing everything out to our ISP, we want to make sure that that system actually balances the traffic based on what's actually going on with network traffic at the time. So that if there's not a lot of traffic going on in the internal, it can balance out if there's a lot of stuff going on the external. If there's not much happening on the external, but our internal users are gearing up and making new content and doing a lot of videos, a lot of audio, MP3, podcast kind of things, right? We want to make sure that the network will allocate bandwidth for users on the fly. The good part is that most Cisco systems will do this automatically, and so will a lot of F5, and they're really famous for load balancing, right? So, and that will help us accommodate all the mobile systems, iPads, iPhones, and all the rest. So we want to automate as much of this as possible. So we're going to use Cisco Network Management, and then we're going to use as much automation for information security like IPSs. Right? Security walls, firewalls, and intrusion prevention. Cisco picks, it's a decent firewall. They still make them. It's an intrusion detection and prevention as well. So we can have everything rolled into one box. We just want to make sure that that box has got enough memory, enough RAM, enough speed, enough CPU processing power to do this. Cisco actually works on what's called a modular design. So you actually buy specific cards to do a specific function. So you buy a firewall with a firewall card. You can actually buy the IPS card that goes along with it. So the thing about IPS and IDS, intrusion prevention and detection, are that they're role-based. So they require a lot of time to set up, but once it's set up, it's managed very easily. And the same thing with firewall roles. Anything that's role-based, you kind of need to know what's going on in your network first. When you're working with your external clients, your guest network, you don't know what's going to come in that door, what the students are doing, what they're bringing, what they're wanting to do, what they're downloading, or otherwise. So you're only going to be able to develop these rules over time, right, based on what your network behavior is. So that's one thing to remember. They're really hard to set up, but once you've got them set up, they're good. We're going to want, for authentication, I'm going to recommend that we use Radius linked back to Active Directory if it's a Microsoft network, or LDAP for a Unix-based network. Radius is easily configured. It's mostly a pass-through for going back and authenticating someone against an Active Directory or LDAP. You can set it up to run locally, but then that requires a lot more overhead and management at the actual wireless access point. And then those credentials don't transfer wireless access point to access point. And it would be kind of difficult for a consumer or an instructor or a student to actually have to authenticate against every single wireless access point for that time. So now another thing that kind of cropped up, and I thought this was interesting, was MAC address authentication. So you can also use Radius for that, but there's some downside to MAC that we're going to talk about here in a minute. So AD or LDAP, if we use the pass-through redirect for authentication for the internal network like I want to do, right, with our terms of service and username and password, Radius will pass that authentication back to Active Directory or LDAP, and we can specify whether it's encrypted so that the username and password can't be captured. If we don't use Radius and we only use an HTTP page for the terms of service username and login back, then we're going to want to make sure that page is SSL encrypted and that the values passed back to Active Directory or LDAP are either hash values and not the plain text username and password, because we want to make sure that those can't be intercepted off the network. So we either want to send back a hash value, and a hash value is basically a mathematical construct of that username and password, or we want to use Radius. Radius will just make life tons easier. Now, a MAC address is immediate access control. It's an address that's unique to every single device on the network. So if you have an Android phone, it has its own MAC address. My iPhone has its own MAC address. A MAC address is basically a number. It's a hexadecimal value for a device. The first three numbers are always going to be your manufacturer. So Apple is 001 Charlie B3. And Microsoft would be different, and Cisco would be different. So you can kind of pin it down by devices. The remaining devices' numbers are unique to itself. Now, the downside is that MAC addresses have been easily forged or hacked since 1999. So while your Radius server can check the MAC address, it works only to authenticate hardware, and that's one thing I really want people to understand, is that it's just hardware only, and it's by device type. You can do it by manufacturer, but then you have to have a nice homogeneous network, a network where all the devices are the same, right? And you still need to have a username and password, right? So if you don't have an environment where you know what all the devices are, MAC address becomes kind of a pain to manage and maintain, because you're going to need to register every device, that comes onto your network. So the student would have to come to the help desk, have you grab the MAC address of their device so you could pre-authorize it, and then you have to push that down to the Radius server. So there's a number of steps, and there's some very big management overhead, and I know people break their iPhone on a regular basis. So in a bring your own device working environment like a school, using MAC authentication can be really difficult because you don't have the same gear from the same manufacturer all the time, and then MAC addresses are easily hacked. So in going through this, right, if you calculate what services you need to provide and you calculate the bandwidth needs for that, it will help you identify not just the services but how the users of that network are actually going to be able to access everything, right? For me, everything's going to start with calculating bandwidth. It helps know how many devices to purchase when you're going and putting up your wireless access points to make sure that you get all the coverage, the wireless coverage you need, so your customer can get the services that they want. Costs drive needs and service accessibility for users. If you only have $7,000, then you may not be able to go with a Cisco router. You may need to go with something that's more homegrown, right? So you may need to go with something like Linksys rather than going with Cisco, but then you need to think about what the cost is going to be for managing and maintaining that device. Most network equipment manufacturers have a centralized network management or other third-party package that you can use so that everything can be remotely controlled, managed, updated. It depends on how your workflow of the organization is. The organization's got various standards that they use through policy, plans, or procedures, right? I do want our ISP to provide all of our DNS services, so I don't need to build another one, and that I can basically then not have to worry about an external DNS. All I've got to do is worry about protecting my internal DNS system. I would go ahead and use Radius because everyone's got a username and password right now. If I'm going to use a smart card or a smart key to go along with it, well, Radius will work with that too. So if it's something I know, my username and password, and then something I have, like a smart card, then Radius will still work with that. So there's still some room for growth and accommodation as I go through the security cycle, the security development life cycle. And then I'm going to want to automate as much as possible. I want to want as much stuff rules-based so I can track and see using roles to find out if I'm doing a good job or if I'm blocking something I shouldn't be blocking, or if something needs to be opened up, or I can ratchet down something that's not generally used that I thought would be used a whole lot more. All right? Most users, most organizations have the username plus password convention, right? You can use MAC authentication, but in a BYOD environment, you're going to spend a lot of time having people register and everything else. It can be expensive, and it doesn't really limit the need for a username or password. So, kind of going through best practices, feel free to reach out to me at my email address, or you can attend my next virtual conference on Sunday. Going through and taking a look at a lot of how people have designed networks over the last couple of years. This presentation is basically at best practices. It's everything we've learned from people sitting in Lowe's parking lots or not having enough access points to really truly cover a building. I've worked in buildings where they only had 4 or 5 access points for a 1,000-foot building, and you drop off and you have huge dead zones inside the building, which is bad when you're in an office without a wired jack into the wall, and you have no wireless service. You're basically cut off from the organization. So when you're designing this, just remember all the basics. Cut it down into a nice, easy to manage package. Use all the best practices. Use as many of the design documents as you can from whoever your device manufacturer is, or even Cisco, because they've got some really good ideas. But feel free to reach out. Thank you very much. Have a good night.